Hey guys, Andy here with more car advice. So here's something that has probably happened to you or someone you know. You wake up super early for that long planned road trip to somewhere fun and remote. Car is full of gas, snacks are packed, and when you turn on the car, boom, little yellow light shines on your dashboard. Ah! Or how about this? You're driving down the interstate and all is well. Then ding, that pesky malfunction indicator lamp turns on and your heart sinks. Is the motor going to fall out of the chassis at 70 miles per hour? Well, in all likelihood, it won't. But there are reasons for check engine light illumination. A warning indicator is among the most common problems in any vehicle. And it can mean anything from the simplest $10 fix to a problem that could cost hundreds, if not thousands, to repair. The check engine light is part of a vehicle's onboard diagnostic system. Contrary to its name, it doesn't actively monitor the engine at all. Some engine-related systems are included, like the fuel system and air intake, but for the most part it's about emissions issues, sensors and valves and the like. Major mechanical parts don't trigger the check engine light in the vast majority of situations. But before we delve into what those are, keep in mind that a lit check engine light that stays steady is less urgent than a light that blinks or flashes. If that engine light is flashing, you have an emergency that needs to be tended to immediately. Now, if yours lights up, these 11 systems are the most likely culprits. This seemingly unimportant part is likely the top reason for the check engine light to switch on. Luckily, it's also the easiest thing to investigate and fix if there's an issue. The twist-on plastic cap covering the fuel filler neck prevents dirt and moisture from entering the fuel system. But it also performs another role few people know: allowing the fuel system to pressurize. Cars perform a self-check for fuel system leaks in the background. When the system tries to pressurize while the fuel cap is loose, missing, or broken, the computer sees a massive leak, triggering the check engine light. Luckily, worst case scenario, this is a cheap and easy fix. Usually it's just a matter of tightening the cap. But even if the fuel cap needs to be replaced, the cost averages around $80. An oxygen sensor, or O2 sensor, monitors the amount of oxygen in a vehicle's exhaust. An element mounted in the exhaust pipe produces voltage from exhaust oxygen levels, and the voltage is indexed to a value in the onboard diagnostic system. If the value is higher or lower than reference, it triggers a DTC, or diagnostic trouble code. These codes may be one of the reasons the check engine light comes on. Most cars have 2 or more oxygen sensors. Upstream O2 sensors, or pre-catalytic converter oxygen sensors, regulate the air-fuel mixture, while downstream O2 sensors monitor the catalytic converter's efficiency. If it's not replaced, faulty O2 sensor can eventually lead to fuel efficiency issues, rough idling, damage to spark plugs, or even the catalytic converter. An oxygen sensor is an inexpensive piece and simple to change. An average replacement cost is typically between $300 and $400, including parts and labor. For an efficient burn, the engine's air-fuel mixture needs to be perfect. Not only does the amount of fuel need to be metered, but the air taken in also needs to be calculated accurately. The mass airflow sensor performs that role. Positioned in the air intake duct, the sensor's element can get dirty. The connector is relatively exposed under the hood, so a slight impact could crack it or damage the wire. If the mass airflow sensor can't accurately read the engine's air volume, you could risk engine damage by running lean, by not burning as much fuel as it should, or rich, burning excess fuel. So it triggers a check engine light. Prices vary for a mass airflow sensor replacement. Expect somewhere between $292 and $407 for an average of about $350. Spark plugs ignite the air-fuel mixture that enters the combustion chamber. Typically screwed into the intake manifold with the electrodes exposed inside the engine, a tiny but powerful spark starts the controlled explosion that produces engine power. Several things can go wrong with spark plugs. Over time, the electrodes can wear down, or the porcelain insulator can crack. They can be fouled by a flooded engine or oil contamination. They can also overheat if the engine is running too lean. If a spark plug fails to ignite on a consistent basis, it triggers a misfire code in the onboard diagnostic system. Changing one faulty spark plug is around $10 to $25, depending on the engine and its requirements. It's usually best to change them as a set because the others are usually in similar condition. You have as many spark plugs as you have cylinders, so a 6-cylinder engine would be 6 plugs. Still, super cheap fix. The ignition coil delivers the electrical pulse to each spark plug, causing them to spark. It has a, coil of wire inside that magnifies a small electric charge into a much larger one and stores it momentarily. When the engine computer sends the signal, the coil releases the pent-up energy to the spark plug, where it ignites the air-fuel mixture. Most cars have one coil per spark plug. Ignition coils are prone to failure after several years, and premature failure could also occur from driving at extremely high temperatures or extremely wet conditions. If the rubber insulation breaks down, the coil can arc to other metal parts and degrade the charge delivered to the spark plug, or it might not fire at all. Problems include poor fuel economy, decreased engine power, and the check engine light can come on for a misfire code. It's a straightforward repair to swap out an ignition coil for most cars. On average, it's between $201 and $269 per ignition coil, with most of the cost being parts. Some cars deliver the spark from the ignition coil to the spark plug through an insulated cable. Ignition cables, also known as ignition wires or spark plug wires, have a boot on either end to insulate the metal clip from arcing. Wrapped in rubber, the ignition wires are designed to deliver the spark to the spark plug without degradation. Potential problems come along with any kind of damage to a spark plug wire. Cracked wire insulation can cause arcing, usually accompanied by visible burns or discoloration on the spark plug wire. A pinch or impact can sever the wire inside. Any damage causes a misfire because the spark plug can't ignite. Few jobs are as easy as changing out spark plug wires. To replace a whole set, expect to pay between $184 and $222 for parts and labor. Whether you have a gas-powered car or a vehicle with a diesel engine, each cylinder has a fuel injector. It's a small, electronically activated valve that regulates how much fuel is sprayed into the cylinder during the intake cycle. The fuel your engine burns tends to have impurities. Those impurities, as well as carbon from the combustion process, can cause the minuscule holes in the injector tip to plug or clog altogether. Occasionally, a fuel injector can be completely clogged, and an injector can stick open and continuously leak fuel into the cylinder. A faulty fuel injector can cause the engine to run rough because of a misfire from either too little or too much fuel. This might only show up when you're heavy on the throttle. Fuel injectors are very precise metering devices, and they're costly as a result. Replacing a fuel injector averages around $720 per injector. Car systems like the throttle, emissions, and power brakes use engine vacuum pressure to assist them. Hoses and valves draw a vacuum from the engine's intake manifold. Should one of those hoses break or be dislodged, or if a valve gets stuck open, the onboard diagnostics usually sees a leak. You might notice the engine idling faster, running rough, stalling, or making a whistling sound, but it's a safe bet the check engine light comes on. Repairing the problem could be as simple as reconnecting a hose, or as expensive as replacing a cracked intake manifold for $1,000 or more. It really depends on the root cause. Well, this one is a mouthful. In the emissions control system, fuel can evaporate, but the vapors escaping into the atmosphere can be harmful. An evaporative emissions system canister filters fuel vapor and condenses them back into the fuel, but some vapors remain. The evaporative purge control valve releases those vapors into the combustion chamber to be burnt off rather than letting them go into the air. Before I run out of breath, let's just call it the valve for now. Now the valve can become plugged, stick open, or get stuck shut, especially if you don't change your engine oil regularly. The connector can also corrode and lose communication with the valve. When that happens, the onboard computer triggers an emissions-related DTC and the check engine light comes on. A faulty valve can result in reduced gas mileage, higher emissions, reduced power, and can cause serious engine damage. Between the parts and labor, the average purge valve is between $110 and $170. A car's engine runs best between 195 and 220 degrees Fahrenheit. Lower temperatures require more fuel to run properly, while higher temperatures create more harmful emissions. The engine thermostat regulates the coolant temperature, and it contains a wax pellet that controls when it opens and closes. As the temperature reaches the right zone, the thermostat opens to allow the coolant to flow into the radiator. The thermostat closes when it cools below that comfy zone. Thermostats are simple devices, but they're likely to fail at some point. Poor maintenance can mean calcified deposits get stuck in the thermostat, keeping it open so the engine doesn't achieve the best temperature. The thermostat can also close, causing high temperatures or overheating. Both are reasons the check engine light would come on. Changing out a thermostat on most cars is a routine job for pros and DIYers alike. Average costs are around $231 for parts and labor if you have a shop do the work. When gasoline burns in the engine, the chemical reaction creates compounds like nitrous oxides and hydrocarbons that enter the atmosphere. Because these harmful chemicals contribute to smog and poor air quality, catalytic converters were implemented in the late 1960s. Shaped like a muffler, the converter's interior has a ceramic honeycomb-like structure covered in reactive elements such as platinum, which triggers a response when exposed to the aforementioned chemicals. The converter superheats the compounds and breaks them down into non-smog forming molecules such as carbon dioxide and water that exit the tailpipe. Low-quality fuel and worn engines that burn oil tend to contaminate the interior of a catalytic converter, causing it to overheat and break apart. When the catalytic converter isn't operating efficiently anymore, a downstream oxygen sensor detects a change and triggers the check engine light. As one of the more expensive repairs related to the check engine light, platinum, remember, replacing a faulty catalytic converter might make you fidget. Expect a bill of around $1,850. So your check engine light has come on. You checked the gas cap, and there ends your expertise. Now what? Well, the onboard diagnostic system has an access port under the dashboard. This is the connector you'll tap into whenever it's necessary to delve into the vehicle's computers to diagnose a problem. It's a 16-pin connector shaped like an inverted trapezoid. The DTCs stored in the control modules need to be deciphered to discover what the problem is, and a code reader is what you'll require to do that. Until the widespread implementation of OBD2 technology in the mid-1990s, code readers were mostly make-specific and usually required a specialized tech to scan for codes. With OBD2 and newer standards, most scan tools or code readers can find the fault codes or DTCs for almost any make and model, at least for check engine light causes. Reading trouble codes requires an OBD2 compatible scan tool. Plug it into the OBD connector under the dash, and after following the prompts on the device, read the DTCs. Each code is 5 digits, beginning with 1 letter and followed by 4 numbers. The exception is for manufacturer-specific codes that may include additional letters in the trouble code. For fault codes common to all models, the code begins with a P followed by a 0. After that, the next number is specific to the subsystem where the fault resides. Here's a handy list to reference or screen grab for common problems. Get ready to pause. Code readers range from beginner models that have like 2 buttons to professional grade devices that can diagnose near everything in the right hands. Basic units will likely only provide diagnostic codes for check engine lights, while more advanced tools could scan for anti-lock braking and airbag system codes, and perform high-level systems tests. You may wonder if you can use the code to fix the problem yourself. Well, think of a DTC like a scavenger hunt. Once you have a clue, you can begin to solve the problem. Codes are like that. They don't bring you right to the solution in many cases, but they point you in the right direction of where you should search for the problem. Unfortunately, it's rarely as simple as changing out a part, and chances are you need to rely on mechanical knowledge and diagnostic skills beyond just DTCs. If you possess those skills, great, have at it. But if your issue goes beyond a loose gas cap or replacing a set of spark plugs, you're most likely best off going to a professional. Ever get a check engine light alert that wasn't related to one of the problems we covered? Help out and let everyone know in the comments. And if you liked our video or found it useful, show us some love with a thumbs up. Also, don't forget to subscribe for more automotive guides and how-tos. And finally, check your gas cap. It might be loose. Till next time.